Welcome. In this video, we are going to look at problem 2 from chapter 4 of College Physics 2E by OpenStax. In this problem, we have the sprinter from the previous problem, and we know that now he accelerates at that rate that was given in problem 1 for 20 meters and then maintains that velocity for the rest of the 100-meter dash, and now we need to find his time for the race. All right, so let's write down what we know. We know that from the previous problem that his mass is 63.0 kilograms. We know his acceleration is 4.20 meters per second squared. Okay, from this problem, we can assume he starts from rest. So his initial velocity is 0. We can assume he starts at 0 meters, and then we know he reaches 20 meters. We can find the velocity at that point, and we need to find the total time for the race. All right, so let's find the velocity when he gets to the 20-meter point. So when x is equal to 20 meters. Okay, so we can use v squared is equal to v naught squared plus 2a times x minus x naught. We are looking for v, so we want the square root of, okay, v naught is 0 meters per second. We're going to square that. Plus 2 times the acceleration. Acceleration is 4.20 meters per second squared. We're going to multiply that by x minus x naught. X final position is 20 meters minus starting position 0 meters. Okay, this gives a velocity. We're going to pick the positive velocity. We assume he's running in the positive direction. So this gives a velocity of 12.96 meters per second. Okay, so on the timeline, so here is when time is 0, so initial velocity is 0, starting position is 0. Then he's going to have an acceleration of 4.20 meters per second squared. We just found the velocity at the end of this period is 12.96 meters per second, and his position is 20 meters. Then he has no acceleration. He's going to maintain the 12.96 until the end of the race. And so at the end of the race, v is still 12.96 meters per second. And now it's a 100-meter dash, so his final position is 100 meters. All right, so we can find the time for the first part when he is accelerating, and then the time for the second part when he's not accelerating. We can add those two times together. All right, so for the first part of the race, we can use x is x naught plus v naught t plus 1/2 a t squared. And we're looking for t. Well, he starts from rest, so that one is 0 meters. And he starts with 0 initial velocity. And we'll just tack subscript 1s. Okay, so this term is gone and this term is gone because we have 0. 0, and then we have 0 times the time. So we have x is 1/2 a t1 squared. So t1 squared is 2x over a. And so that's going to be 2 times the 20 meters divided by 4.20 meters per second squared. This gives a time of 3.086 seconds. Now for the second part of the race where he is not accelerating, we can use velocity is displacement per time. We'll tack a 2 on there. And so velocity times t2 is the displacement. So t2 is going to be the displacement divided by velocity. Okay, we know it's going to be 80. The final position is 100 meters minus where this part started was at the 20 meters. So that gives us the 80. And we'll divide by the 12.96 meters per second. This gives a time of 6.172 seconds. Okay, now the total time t is going to be t1 plus t2. So that is going to be 3.086 seconds plus 6.172 seconds. Okay. This made 9.258 seconds. And so to 3 sig figs, it is 9.26 seconds. That's how long it takes him to run the 100 meters when he accelerates in the first 20 meters. And then it's not coasting, but he maintains his velocity for the remainder. I hope you found that helpful. Let me know in the comment section if you have any questions. Thank you for watching, and I'll see you in the next one.